Now we are going to study intermolecular forces, 7.3. Okay, before that, you have to know these two words, polar. He also got polar. What is the difference? Bond, you see here, bond, here molecule. You have to differentiate these two. Polar bond, polar molecule. When we call polar bond and when we call polar molecule. And don't confuse with these two. Okay, now let us see one by one. When we call polar bond, a bond between atoms of different electronegativities in which the distribution of the density of the bonding electron pair is asymmetrical. Asymmetrical means not balanced, not symmetry. Okay, so for example, I choose one molecule here, HF. Okay, I want to know this bond, is it polar bond? I want to know. Okay, first should be a covalent bond. Okay, sharing of electron. Okay, must have atoms with different electronegativity. So hydrogen and fluorine, different electronegativity. You can see here, these two atoms have different electronegativity. So the distribution of the density of bonding electron pair, which one? This one. Here got the electron pair, bonding electron pair. So the distribution of this density of electron is not symmetrical, is asymmetrical. Okay, what is the meaning of distribution of the density of bonding electron pair is asymmetrical? Okay, I want to show here. Okay, let's see this diagram. I got the atom hydrogen, atom fluorine. Okay. Which atom got tendency to attract electron towards itself greater? We call as electronegativity. What is the meaning of electronegativity? We already studied before this. Tendency to attract electron towards itself. That means here got bonding pair electron. This one is what? Bonding pair electrons. So which atom got tendency to attract this bonding pair electron towards itself? Which atom got the greater tendency to attract the electron towards itself? Is it fluorine or hydrogen? So you have to see the electronegativity. Which atom got higher electronegativity? Still remember the lesson we studied before this? Electronegativity across the period. Is it increases or decreases? Electronegativity increases. Okay, if electronegativity increases, which atom got the higher electronegativity? Fluorine. Because fluorine is group 17. So fluorine got a higher tendency to attract this bonding pair electron towards itself. So that's why you can see here, this electron density here already attracted to fluorine. You see the size here, the size of the electron cloud. You see, larger. You can see here, larger. Okay, quite large. Okay, compare that the electron density on the hydrogen side. Okay, this is hydrogen side. Is smaller, big. So this area is rich with electron. This area poor with electron. So all the bonding pair electron already attracted towards hydrogen. Towards fluorine. Why? Because fluorine got higher electronegativity. Fluorine got higher tendency to attract electron towards itself. So that's why you can see the electron cloud like this. If the electron pair distribution is asymmetrical, you see here, not symmetry. You see one side is large, one side is smaller. So this one is not a symmetry, asymmetrical. If like this bond is polar bond. Polar bond. The bond between hydrogen and fluorine we call as polar bond. Okay, I discuss another example here. I got chlorine and chlorine. Is it this bond is polar bond? Okay, so let us see the electron cloud. So let's say CCl. So let us see the electron cloud. Okay. First thing, I have to check, is it got different atoms? No, same atom. It's not different. Huh? Here also got atom chlorine, this side also got atom chlorine, same atom. If same atom will have same electronegativity, that means tendency to attract this bonding pair electron will be same. Tendency, no any atom can pull closer, no, same. Because atoms are same, electronegativity are same. So how will be the distribution of the density of bonding pair? Will be symmetry. You can see a symmetry. Same. One side is not too large, one side is not too small. Same. So this one, distribution of it, density of bonding pair electron are symmetrical. Same. Okay, same. Or you. So this bond, is it polar bond? Anyone? Is it this bond is polar bond?
No.
No. No. The answer is no. Okay, now let us see polar molecule. When we call polar molecule, okay, we already studied polar bond. Now let us study polar molecule. A dipole molecule in which the positive and negative poles can be distinguished because of the separation of the charges. Okay, so positive poles. What is the meaning of positive poles? How to draw positive poles? Delta positive. After that, how to draw negative poles? Delta negative. Okay, so polar molecule. So in your molecule will have positive and negative poles. Okay, let us see. HF. HF. Okay, I choose HF. H and F. Which atom is more electronegative? Fluorine. That means fluorine got higher tendency to attract electrons. So here will be delta negative. Why delta negative? Because more electron towards moving towards to the fluorine. Hydrogen, less electron because electronegativity is lower than fluorine. So here will be positive pole. Why positive pole? Because less electron. Okay, less electron. So this molecule we call as polar molecule. This molecule we call as polar molecule. Because got delta positive and delta negative. Let us see Cl and Cl. Is it this molecule is polar molecule? Okay, let us do the positive and negative dipole. Chlorine, negative dipole because more electronegative. Chlorine here also delta negative. You see, both also same dipoles. So this one is not a polar molecule. It's not a polar molecule because we got a positive dipole. This one is not a polar molecule. We call as non-polar molecule. Non-polar molecules or non-polar molecules. Okay. What is the behavior of polar molecule? Just now we already studied how to identify polar molecule. And what is the behavior? What is the characteristic of polar molecule in an electric field? Okay, so let's say I got a electric field here. I got a plate. I got a positive plate here. I got a negative plate here. So here the electric current is off. Electric field does not have a current yet because we already switched off. So when switch off, you can see the molecule is moving randomly. So positive, negative, what is this positive and negative? The delta positive, delta negative. Delta positive, delta negative. What happened when you switch on the electric field? What happened when you switch on the electric current? So here got a positive plate. So the negative pole will attract to the positive plate. The negative pole, delta negative, will attract to the positive plate. What happened to the positive pole? Positive poles will attract to the negative plate. That means negative go to positive, positive will go to negative in the electric field. So this is the behavior of the polar molecule, characteristic of the polar molecule. Now we want to study what is the meaning of bond polarity. Before this, we already studied polar bond, polar molecule, and after that, we already studied what is positive dipole and negative dipole and how to label. Now, what is the meaning of bond polarity? Okay, let us see the lesson. Atoms with different electronegativity form polar bonds. Yes, this one we already discussed before this. If you want to get a polar bond, you should have different electronegativity atoms. Then only you can form a polar bond. If got same electronegativity atoms, you cannot form a polar bond. Okay. Now I want to draw polar arrow. So what is the style? Okay, the style will be like this. Okay. So this is how you're going to draw polar arrow. Okay. For my student, okay. So easy to remember, just it's not in the book. Just for my student, I always label this one as head, this one as tail. Okay. So how to draw this polar arrow and which side the head should be and which side the tail should be. Head, is it going left, right, up, down, or how? Okay, so now let us see a few example here. I got carbon and atom chlorine here. Is it this bond polar bond? Okay, let us check. Is it got two different electronegativity atom? Yes. I got carbon and chlorine. Which atom is more electronegative? Chlorine. So tendency to attract bonding electron pair towards itself is greater. So the electron density, the distribution to atom chlorine will be higher. So that's why we label dipole negative. Why carbon we label with dipole positive? Because carbon less electronegative. Tendency to attract electron towards itself is less. So the region, the area around carbon is less electron. That's why we label dipole positive. Now I can draw polar arrow here. So the head should be faced to the more electronegative atom. This head should be faced to more electronegative atom or delta negative. The tail, okay, the tail should be at less, should be at less electronegative atom, or we can label as delta positive or dipole positive. So now let us draw polar arrow, this molecule. So you can see the tail at carbon, because carbon is less electronegative, and you can see the head at more electronegative because chlorine is more electronegative. So you see polar arrow. If got polar arrow, the bond is polar bond. If you can draw polar arrow, the bond, this bond is polar bond. Polar bond. Yes. Okay, let us see another example. This one. Carbon, carbon. These two atoms are same electronegative. Tendency to attract these bonding electron pair are equal. So the distribution of electron density are equal, both sides. So you cannot label dipole positive or dipole negative. No dipole here, no dipole. Because you cannot draw dipole positive or dipole negative. So you cannot draw polar arrow here. Cannot draw polar arrow. So if you cannot draw polar arrow, this bond is non-polar bond. Okay, this bond is non-polar bond. Now you already learned how to draw polar arrow. Okay, now what is dipole moment? And what is the symbol we use for dipole moment? Small letter of M. What is dipole moment? A quantity measurement, that means got a value of a molecular polarity. Will have a value because they say quantitative measurement. So how to measure dipole moment? How to measure the dipole moment? And let us see what is the definition. The product of the magnitude of the charge, dipole positive, and the distance d that separates the center of positive and negative charge. So this is the formula to calculate dipole moment. So mu we call as mu. Okay, q is the charge, r is the distance. This is the formula. Q is the charge, r is the distance between the charge. Between the charge means between delta positive and delta negative, the distance. Okay, and you will get a value. So here our dipole moment can be 0 or is not 0. That is the value of dipole moment. Only will have two value. What is the value for dipole moment? Mu equal to 0 or mu is not equal to 0. Okay, so that is the value for dipole moment. Okay, now let us see another term. What is resultant dipole moment? What is the lesson we studied just now? Mu equal to 0 or mu is not equal to 0. This is the two values for dipole moment. This is the two values for dipole moments. Okay. So now what is resultant or net overall? Dipole moment we call as resultant. Resultant means overall, net dipole moment. How you can get the answer? Determined by molecular shape and bond polarity. If resultant dipole moment is not equal to 0, resultant dipole moment, if resultant dipole moment is not equal to 0, so that molecule is polar molecule. That molecule is polar molecule. If resultant dipole moment is equal to 0, so that molecule is non-polar molecule. So we are going to apply this in your molecular shape. Now, how to apply? We are going to learn now. How to do dipole moment, how to do resultant dipole moment in the molecular shape. That is 7.3. So what basic you have to know? You have to know bond dipole, you have to know dipole positive, dipole negative, and you have to know dipole arrow, polar, how to draw bond dipole. Okay, so now let us see how we can apply dipole moment and resultant dipole moment in my molecular shape. how to draw polar arrow. Okay, we already studied before this, but let us recall back. Let's say this is my molecule. Okay, so first step I have to check. I have to check, is it this bond polar bond? I have to check. First, got two different electronegativity atom. Okay, if got two different electronegativity atom, one will be more electronegative, one will be less electronegative. So if more electronegative, tendency to attract electron towards itself will be greater. So you can see this area will be rich with electron. So I can label delta negative, dipole negative. If the atom is less electronegative, tendency to attract electron will be less. So you can see this area around hydrogen, electron poor region. So I can label dipole positive. Okay, so got dipole positive, got dipole negative. Now I can draw polar arrow. I can draw polar arrow. Polar arrow, I already informed to you, will have head and will have tail. This head will face to the more electronegative atom, and the tail will at the less electronegative atom. So your polar arrow will be like this. Start at that atom, stop at that start at less electronegative atom and stop at more electronegative atom. If you draw like this, it's wrong. Okay, your polar arrow is wrong. No. Polar arrow should be at atom to atom, not to the bond. Okay, so now you can see here got polar arrow. If got polar arrow, the molecule is polar molecule. If polar molecule, dipole moment. Dipole moment, mu is not equal to 0. Mu is not equal to 0. So this molecule is polar molecule. Let us see another example. Non-polar molecule. Non-polar molecule. Okay. Here I got two atoms, Cl, Cl. So is it this bond, polar bond? Okay, two different same electronegativity atoms. That means tendency to attract electron towards itself is same. So you cannot draw dipole. You cannot draw dipole positive or dipole negative. And you also cannot draw polar arrow. If you cannot draw dipole positive, dipole negative, you also cannot draw polar arrow. So this bond we call as non-polar bond. Non-polar bond, you see, non-polar bond. And what happened to dipole moment? Dipole moment is mu equal to 0. If mu equal to 0, that molecule is non-polar molecule. Molecule means this one, the overall. This molecule is non-polar molecule. Okay, and please differentiate, differentiate. When we Cl, this one we focus to bond. If overall we call as molecule. Okay, because you have to differentiate bond, you have to differentiate this word bond and molecule. Don't confuse. How to determine a molecule is polar or non-polar molecule? How I want to know if given a molecule to me, how I can identify that molecule is polar or non-polar molecule. So what is your first step? You have to draw Lewis structure of the molecule and calculate the formal charge. From the calculation of formal charge, you can predict the most stable Lewis structure. So this one we already learned in 7.1. So the most stable Lewis structure we are going to bring to 7.2. We are going to identify the class of compound. After that, we use valence shell electron pair repulsion theory. We are going to predict the molecular shape. So this one will be your 7.2. I already know my molecular shape. So using my molecular shape, I'm using my molecular shape which I already predicted. I'm going to use electronegativity value to predict the bond dipole. After that, I want to predict is it my molecule is polar or non-polar. How? If the bond dipole can cancel out or combine to produce a resultant dipole. Okay, this is the one you are going to see after this. What happened if in your molecule got two bond dipole? Okay, if just now what is the lesson we study? H, F. H, F only will have one polar arrow. So this molecule is polar molecule. Easy, we can identify the answer. But what happened if the molecule given to me, I got more than one bond dipole? How to predict? Is it the molecule is non-polar or not, or polar molecule? How to predict the dipole moment? So this one will be your 7.3. This lesson will be your 7.3. Okay, now let us explore our 7.3. If in a molecule got more than one polar arrow, or another name we call as bond dipole. Okay, let us see how to do it. Okay, here they already give you a summary. The summary for you to identify the answer. So let us see the first conclusion. Diatomic molecules, di means two atoms will be in that molecule with two identical atoms. Identical means same. Okay, so for example, Cl and Cl is diatomic molecule. Is it same? Two also same chlorine atom. So automatic this molecule will be non-polar molecule. Okay, let us say number two. Number two. Diatomic molecules with different electronegativity. For example, H, F, two different electronegativity atoms. So this molecule will be polar molecule. Okay. Now, number 3, molecule with symmetrical shape. Okay, molecule with symmetrical shape. We are going to see after this. Symmetrical shape means the distribution of the electron will be equal. Okay, and bond dipole also will be equal at the same both side. If like that, that molecule will be non-polar molecule. We are going to learn now what is this. Number 4, molecule with asymmetrical shape. That means the arrangement of the bond dipole is not asymmetrical. So your answer, molecule can be polar or non-polar. Okay. So I think 1 and 2 you already can understand because we already discussed. Now we want to do 3 and 4. 3 and 4 means in your molecule you will have more number of atoms, or you will have more bond dipole, you will have more polar arrow. So if like that, how I can identify polar or non-polar? So that is case number 3 and number 4. So we want to do now. Diatomic molecules. Diatomic means will have two atoms with different atoms. So for example, I got X, I got Y. Two different atoms. So covalent bond between of the atoms, this bond is polar bond, not non-polar. Covalent bond between atoms of the same element, not the same, different. Different element is polar bond. So that means this bond is polar bond. Okay, the molecules are polar molecules. These molecules are polar molecules. The bonding electron are shared not equal. Okay, so here got few example. Let us see few example here. I got ICl. Okay, so I want to know this bond polar bond or not. So which atom is more electronegative? Chlorine. So here the dipole negative, here dipole positive. I can draw bond dipole polar arrow. Okay, so this molecule is polar molecule. So the dipole moment mu is not equal to 0. Let us see another example. H, F. Okay, this bond, polar bond. Okay, this bond is polar bond. Two different electronegativity atoms. So got a bond, got a dipole. This one is dipole positive, sorry, dipole negative. So here will be dipole positive. So this, here I can draw bond dipole or polar arrow. So this molecule mu is not equal to 0. So this molecule is polar molecule. Okay, so this is number 2, type number 2. Okay, now let us see type number 3. What is type number 3? Type number 3, molecule with symmetrical shape. How you see left, right, up, down, all is same. That is the meaning of symmetrical shape. Okay, so let me see this example. B, F, 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 trigonal planar. So let us see how to label dipole. Dipole positive, dipole negative. Which atom is more electronegative? Fluorine. So fluorine here will be dipole negative, here dipole negative, dipole negative, here dipole positive. And I can draw bond dipole. Bond dipole or polar arrow. So from the less electronegative to more electronegative. From the less electronegative to more electronegative. From the less electronegative atom to more electronegative atom. Okay, I already draw. You want to draw down here also can, no problem. Okay, like this. You want to draw like this also can, no problem. Why I never draw down? Because no space clash. That's why I draw here. Okay, you want to draw like this also can, no problem. Okay, okay. I already draw bond dipole. Okay, now is it this is symmetry? Okay, let us cut half. You see left and right. Up I got F, left hand side I got F. When I see on my right hand side, up also I got F, below here also I got F. So that means symmetry. Okay, is symmetry. Okay, and let us see bond dipole. This bond dipole, if symmetry, if one bond dipole going up, another bond dipole going down, these two can cancel out each other. Can cancel out each other. But we won't show in the image, no. If one going up, one going down, you can see here, one going up, one going down, facing down. So these two bond dipole can cancel out each other. This one still can cancel out with this other because opposite direction. Okay, so here you have to explain. How many bond dipole? 3. 1, 2, 3. 3 bond dipoles can cancel out each other because in opposite direction. Okay, in opposite direction. If can cancel out each other, so in the structure, no more bond dipole, no more already because already cancel out each other. If can cancel out each other, mu will equal to 0. The molecule is non-polar molecule. Because no more bond dipole, all already cancel out each other. So the value, no value, dipole moment, no value, 0. So conclusion, non-polar molecule. And I hope you all still remember this word, resultant. Resultant dipole moment. Okay, where is the resultant dipole moment? Okay, you see here, one bond dipole going up, two bond dipole going down. So the bond electron pair, which side is attract much? Is it up or down? Facing down. Because only one bond dipole going up. Two bond dipole you see going down, facing to more electronegative atom. That means the bonding electron more is attract towards downwards. So the resultant dipole is facing down. So you can draw one big bond dipole. You can draw one big bond dipole until the like this. And you can label resultant dipole. You can label, you have to label resultant. You have to label. After you already draw this arrow, you have to label this one. Resultant dipole moment. Okay, some book they draw like this. They draw a bond dipole quite large. Or you also can draw like this, same. You want to draw like this also can. So this is the way how you are going to draw resultant dipole moment. Okay, so now let us say CO2, another example. CO2, another example. Carbon and oxygen. So which one is more electronegative? Oxygen, this is delta positive, this is delta negative. So I can draw bond dipole from carbon to oxygen, from carbon to oxygen. Okay, finish. This is what we studied before this. Now, is it these two bond dipole can cancel out each other? When can cancel out each other? In an opposite direction, up, down, or left, right. Okay. Can cancel out each other. Cancel out each other. Okay, so this bond dipole can cancel out each other because in an opposite direction. Is it symmetrical? Is it symmetrical? Let us see. If you cut here, is it same? Left O, right also O, center carbon. So it's symmetrical. Okay, it's symmetrical. Okay, it's symmetrical. So how to explain? You have to explain the same point. This point should explain here, but it's not 3. It's not 3. How many bond dipole here? 2. So 2 bond dipole can cancel out each other because in an opposite direction. If can cancel out each other, the mu is equal to 0. So this molecule is non-polar molecule. Is it a resultant dipole moment? Can I draw resultant dipole moment? No, cannot. Because the tendency to attract the bonding electron pair are equal. You see, left, right are same. Okay. Can you follow so far?
Yes, sir.
Yes, sir.
Yes, sir.
So now let us see another example. PCl5, trigonal bipyramidal. Which electron is more electronegative? Chlorine. So dipole negative, dipole negative, dipole negative, dipole negative, dipole negative, here dipole positive. That's why you have to draw larger a bit. because easy for you to label the dipole. Can I draw a bond dipole? Yes. From less electronegative to more electronegative. So I can draw 5 bond dipoles. I can draw 5 bond dipoles. Okay. Is it symmetry? Is it symmetry? You see, center here I got P, here I got Cl, left up, facing up I got 2Cl, and this side facing down also I got 2Cl, same size, same space. So it's symmetry. Okay, now is it this bond dipole can cancel out each other? You have to use these two concepts. Okay, you have to say this Cl with this Cl. Is it these two in opposite direction? This concept. Is it? So these two bond dipole can cancel out each other. Okay. Now these 3 bond dipole, you have to use this concept. Sorry, class. For this one, we follow this one. We follow this concept. Left. You can use up, down, or left, right. Your wish. For this one, we follow this concept. This bond dipole can cancel out with this bond dipole. Okay, because in opposite direction, one up, one down. This bond dipole can cancel out with this bond dipole because in opposite direction, one going up, one going down. So all the 5 bond dipole can cancel out each other. Cancel, 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 cancel. But don't show in your image. No, we cannot show. Wrong. Don't do like this. It's wrong. How I want to show all the bond dipole already cancel out each other. How? You have to write this statement. So how many bond dipole? 5. Bond dipole can cancel out each other because in an opposite direction. Mu equal to 0, this molecule is non-polar molecule. Okay, is it got a resultant dipole moment? Let us check. Is it got resultant dipole moment? When I say up, down here, no, because the tendency to attract electrons are same. When I say like this, yes, because one dipole is up, two dipole is down. So that means the tendency to attract the bond electron pair is much more greater facing like this. So the bond dipole you can draw like this, or you can draw a big arrow. You can draw a big arrow, resultant dipole moment going down. Okay, going down. And don't forget to label resultant. Don't forget to label. Resultant dipole moment. Okay, now let us see type number 4. Type number 4, where my molecule is not symmetrical, asymmetrical. Okay, let us see here. Let us see this one. If you cut like this, is it symmetry? No, because Left, right, I got 2F. Here also I got 2F. But here O, here F, not same. So this is a symmetrical shape. This one also. Okay. If you cut like this, here got 2, here I got 1. Okay, not symmetrical. And one atom is chlorine, the 3 atoms is hydrogen. Okay, so now let us discuss how to do it. Okay, if you cut this one, you see here 2H here, 1H, 1Cl. No, not symmetrical. Okay, let us discuss this question. Let me draw dipole. So which one is more electronegative? I and F. F is more electronegative. Delta negative, delta negative, delta negative, delta negative. Okay. I and O. Which one is more electronegative? Oxygen. So iodine is delta positive. I want to draw bond dipole from less electronegative to more electronegative. So how many bond dipole I can draw? I can draw 1, 2, 3, 4, 5, 6. Which bond dipole can cancel out each other? This one and this one can cancel out each other. This one and this one can cancel out each other. But this one, which one is going up and which one is going down, cannot cancel out each other because the electronegativity atom is not same. One is O, one is F. The tendency to attract electron is not same. So here, how to explain? Bond dipoles cannot cancel out each other because not symmetrical, and not in opposite direction. So if not in opposite direction, the mu is not equal to 0. This molecule is polar molecule. Okay, polar molecule. Let us see another example here. CH3Cl. Let me label dipole. Carbon and hydrogen. Carbon is more electronegative. Hydrogen less electronegative. So dipole positive. Okay. Now you see here, carbon and chlorine. Which one is more electronegative? Chlorine. So chlorine will be delta negative. Carbon will become delta positive.